Hello, my dear students. Hello, my dear students. My name is Lakshminarayana. This is Ellen Brand of Chemistry. Today we are going to discuss about solutions. Solution chapter. Previous year questions that we have to discuss. So come to the live session, all of you. So those are preparing for the JEE Mains and EAPCET examination. So better to listen my classes. That will be useful for you people. For more chemistry classes, subscribe my channel and share my channel to others. Then like it. So come to the live session, all of you. Come to the live session. Hello. Hello, my dear students. Those are preparing for the JEE Mains and EAPCET examination. So listen my classes. These are useful for you people. From the chapter, so look at all of you. First, the most important one that is that we have to discuss in the solutions. It is concentration terms. Concentration terms, if you take, that are, so two types of concentration terms will be there. Two types of concentration terms. Sir, one is mass based, the mass related, another one is volume related. So first we are taking volume related, then one more mass related. So volume related or depends upon the temperature. So these are temperature dependent. Temperature dependent. These are temperature independent. Temperature independent. Temperature independent. Temperature dependent to temperature independent. So what are those temperature dependent that we have to discuss? So that's what that are I told that volume related. So what are those? Number one, that is molarity. It is a volume related. Then one more, weight by volume percentage. Or one more, volume by volume percentage. Then fourth one is normality. All these are depends upon the temperature. Temperature changes or takes place. These concentration terms also changes. Then which are independent? That are number one. So only mass related, that weight by weight percentage, or we call it as by mass percentage. Mass percent we call, by mass percent or weight by weight percentage. Second one, that is molality. Then third one, mole fraction. Then fourth one, so that is parts per million, ppm. So totally 8 concentration terms are there. Even here some cases even parts per billion also they will take. Parts per million and parts per billion. So totally 8 concentration terms are there. Molarity, weight by volume, then volume by volume, then normality, then mass related, weight by weight, molality, mole fraction, parts per million, like this will be there. So now one by one we have to discuss. First one we have to discuss about the molarity. So remember, all these concentration terms are depends upon the temperature. All these concentration terms are independent of the temperature. They will ask a question based on this. Uh, the concentration term, the concentration term which is change with the temperature. So options they will mention like this: A is molarity, then B is molality, then C is mole fraction, then D is nota, none of the above. So like this they will mention. So which is change with the temperature? Molarity is the change with the temperature because volume related. So actually why these are change with the temperature, So according to the Charles law, we know that volume is directly proportional to temperature at constant pressure. At constant pressure, volume is directly proportional to temperature. So volume change avute temperature change aithe volume kuda change avutundi. Volume change aithe then concentration term kuda change avutundi. So that you have to remember these are related with the volume that are depends upon the temperature. Okay, clear? Now we have to discuss about the molarity. So first of all, what is the molarity? What type of questions they will ask based on the molarity, that we'll discuss. What type of questions they will ask based on the molarity, that we'll discuss. So first one, that is molarity. So molarity, nothing but, so that will be represented with a capital M. The number of moles of solute, listen my dear students, the number of moles of solute, the number of moles of solute present in 1 liter of solution. 1 liter of solution. So look at the number of moles of solute present in 1 liter of solution, nothing but is a molarity. So molarity equals to number of moles divided by volume in liters. So units we can take for this, unit same teeskochu, number of moles that you can take it as mole by, so volume units are liters, so that we can take mole liter inverse. These are the units for molarity, right? Yes. So now generally the number of moles can you calculate by using the formula, that is given weight divided by gram molecular weight. Given weight divided by gram molecular weight. So molarity equals to, in the place of small n, nothing but number of moles, that you can take given weight divided by gram molecular weight, sir, into 1 divided by volume in liters, that you have to take. Clear? Sir, in case in the question volume is mentioned in the milliliters, then molarity equals to, sir, given weight divided by gram molecular weight, so into 1000 divided by volume in milliliters. This formula I have to take. Clear? So this is the molarity formula to calculate that. So these are the units for the molarity. So some more formulas we can use for the molarity based. So such as number two, that is M1V1 equals to M2V2. This formula I can use. So this formula when it can use, so when dilute the solution already solution molarity volume తెలిసి ఉన్నప్పుడు దాన్ని dilute చేస్తే ఈ ఫార్ములాని యూజ్ చేయొచ్చు. So these are the formulas. Then some more formulas are there that we'll discuss. So look my dear students. Yes. So next look at, so next what formulas we can use by using the molarity. Which formulas we can use by using the molarity, that is M1 V1 divided by N1, or when the mixture of two solutions, when mixed two solutions which are having the same solute, which are having same solute same గా ఉన్నప్పుడు then molarity ని find out చేయడం ఎలా, that is capital M, it is equals to M1 V1 plus M2 V2 divided by V1 plus V2. ఈ ఫార్ములా యూజ్ చేయాల్సి ఉంటుంది. This formula you can use in case two different solutions. Look at, so for example here the molarity it is mentioned 0.1, volume is mentioned 100 ml. Then one more solution is there, that is molarity 0.2 is mentioned, the volume that is 200 ml is mentioned, both when it is mixed, but the condition is both solutions having the same solute. Yes, look at all of you. Then same solute, then this formula we have to use. Clear? Even with the density and molar mass, the density with molarity, the relation is there. Relation between density or specific gravity, we call specific gravity, even specific gravity also we can use. Then specific gravity with molarity. So what is the relation will be there? So molarity equals to 10 into density into weight by weight percentage. So remember, 10 into density into weight by weight percentage divided by gram molecular weight you have to take. Gram molecular weight. So these are the formulas are there for the molarity concept. Then here molarity general formula you can use, that is molarity equals to, sir, given weight divided by then gram molecular weight into 1000 divided by, so volume in milliliters I told, right? So now given weight is there na, given weight when it is, if you want to calculate, so weight equals to then molarity into, so molarity into these two terms send this side. సో ఇక్కడ రెండు టర్మ్స్ కూడా డివైడ్ చేస్తున్నాయి కాబట్టి ఇటువైపు వస్తే మల్టిప్లై చేస్తాయి. సో వాట్ ఆర్ దోస్? గ్రామ్ మాలిక్యులర్ వెయిట్ then into volume in milliliters divided by what will be there? 1000. So this formula you can use for calculate the weight of solution. Yes, based on this, one of the previous year question is there. So note first formula, then previous question that we'll discuss now. So look, my dear student, one of the previous year question is there based on it. In 2025, this question is given. So question how it will be there. The 2025 May 2nd. The 2025 May 2nd kadigina question idi. Look at the question is, which of the following solution has highest amount of solute? Which of the following solution has highest amount of solute? So like this is given the question. Look at the question carefully. So amount of solute nothing but W you have to calculate, that is weight we have to calculate. So options are mentioned, that is sir, 1 liter of 0.25 molarity of Na2CO3. sodium carbonate. Even molar mass also is then mentioned in the bracket 106. Then B, that is mentioned as then 0.25 liters of 0.25 liters of then 0.2 molarity of Na2SO4 is mentioned. That molecular mass is 142. Then C, that is mentioned 0.5 liters of 0.5 liters of so 1 molarity of KMnO4, that is mentioned KMnO4. So 158 molecular weight is 158. Last option, that is so 0.75 liters of 75 liters of then 0.5 molarity of 0.5 molarity of urea. So urea molecular weight is given 60. So this is the question, which of the following has the highest amount of solute? So highest amount of solute దేనిలో ఉంది అని find out చేయాలి అంటే, sir, I told that the weight formula, that is equal to molarity into then gram molecular weight into then volume in the milliliters divided by 1000 have to take. This is the formula. So if you take for the A, so A కోసం మనం find out చేస్తే, so molarity ఎంత ఇచ్చాడు 0.25, then into gram molecular weight, so 106, then into volume in the milliliters, actually that is given in the liters, so liters లో ఇచ్చాడు అంటే నేను అటు take even that is 1000, right? So into 1, so you can get 106 into 0.5. So here you can find out 0.25, nothing but 1 by 4. 1 by 4 into 10 point 1 by 4 into 10.6, then 10.6 106 divided by 4, then 53 divided by 2, then so 2 to multiply cheyandi, so 2 2s 4, then 13 will be there still, so 2 7s then 27.5, so 27.5 grams are there in the first option, right? Then look at the second option. So how to find out? By using the same formula. So yeah, B option, yes, B option, look at B option, weight equals to molarity, what will be there? 0.2 into molecular weight, what will be there? Molecular weight 142 into then what will be there? So this is liters, 0.25 liters when it is converted into the milliliters, 250 ml, right? 250 divided by 1000, so how many times it will go, man? So once 4 times, right? So 0.1 then divided by 2, right? So 2 when it is multiply with so 2 7 14, so 2 171, 71 into 0.1, 7.1 grams of weight will be there in the B option, right? Then C option, calculate the C option. Actually the C option, the same formula you can use, weight equals to then molarity, 1 molarity is there, then molecular weight 158, then liters 0.5 liters are mentioned, that is converted into the milliliters, so 500 divided by 1000 if you take 1000, if you take, then look at 500 once, so then 2, so 2 when it is divide with this 2 7s 14, 14 still 18 is there, 2 9, so 79 grams, 79 grams. This is the highest amount. So C is the highest amount. Even if you calculate the fourth option also, less amount you can get. So answer is C. Understand, my dear students? So how to find out? By using this formula. So weight of each component you have to find out. So if you find out the weight of component, you can get. Okay, clear? Then one more question, look at. One more question. Based on the molarity itself. Yes, based on the molarity. Second question. So look, my dear students, based on the molarity, what type of question is given? The approximate molarity of solution in the approximate molarity of solution in. So look at mole liter inverse. They are mentioned. Mole liter inverse units are mentioned. That contains 13.50 grams of NaCl dissolved in 452 ml of water. Dissolved in 452 ml of water. This is the formula. This is the question. This question is given in the 2019 May 4th kitchen question. May 4th, 2019 May 4th. Yes, my dear students, look all of you. The molarity formula is what? Molarity equals to number of moles divided by volume in the liters we can take. But here the weight is mentioned, given weight divided by molecular weight into 1000 divided by volume in the milliliters, right? Yes. So here molecular weight, if you want to find out for the NaCl, molecular weight, then you have to take Na, how much is there? Sodium 23, right? Then chlorine, that is 35.5, total 58.5. This is the molar mass of NaCl. Yes, given weight is 13.5. So in the place of weight, you have to take it as 13.5 divided by molecular weight 58.5 into 1000 divided by volume. How much is given? 452 ml. So 452 ml. Then if you use this calculation, you can get 0.51 mole liter inverse. These are the question. Actually options are 0.25, 0.51, then 1.0, then 1.2, like this will be there. So second option is correct answer for this. Okay, understand, my dear students? So this is about the molarity. This is about the molarity. Then in case some other concentration terms, what are those? Normality, then mole fraction, then molality. So all the concentration terms if you want to calculate. So what is the mole normality? Normality is what? Normality, nothing but the number of moles of, the number of gram equivalents of solute present in 1 liter of solution. 1 liter of solution. This is the definition for the normality, right? Normality equals to number of gram equivalents divided by volume in liters. Volume in the liters. Sir, what is the number of gram equivalents? The previous in the molarity we are calculated number of moles divided by volume in liters. But the normality, number of gram equivalents divided by volume in liters. So what is the number of gram equivalents, man? Number of gram equivalents formula enti? So gram equivalents formula, that is equals to then given weight divided by gram equivalent weight. This is the formula. Yes. Is that visible, my dear students? Is that visible? The formula is visible to you, right? Very good. Yes, number of gram equivalents, it is equals to weight divided by gram equivalent weight. So normality formula you can use weight divided by then gram equivalent weight into 1 divided by volume in liters, right? 1 divided by volume in liters. Then in case in the milliliters is there, Sir, given weight divided by gram equivalent weight into then 1000 divided by, so volume in milliliters you have to take. Milliliters you have to take. So look at, understand all of you? Yes, right. So now other formulas also is there that are then N1 V1 equals to N2 V2 when it is when dilute known molarity of solution. Known molarity of solution. Then when it is diluted resultant solution, if they will ask that, we have to take. Then one more formula, man. So resultant molarity when both are mixed, when both two solutions are mixed, resultant normality equals to N1 V1 plus N2 V2 divided by then V1 plus V2. This formula you can use. So when it is two solutions, when two solutions are mixed, so రెండిటిని మిక్స్ చేసినప్పుడు, so this we can use, so mixed. Sir, but condition is in both solutions solute must be same. Even one more formula, same like molarity. One more formula, man. Yes, one more formula, that is normality. If you want to find out when density is given, then density into 10 into weight by weight percentage divided by, you have to take here gram equivalent weight, not gram molecular weight. Gram equivalent weight. Sir, everyone, we have a doubt here. So what is the gram equivalent weight? We know the gram molecular weight, but what is the gram equivalent weight? Right? So gram equivalent weight equals to gram molecular weight divided by n factor. This is the formula you have to use. Gram equivalent weight find out cheyalante gram molecular weight divided by n factor తీసుకోవాలి. Again you have a doubt, what is the n factor? So what is n factor? N factor enti? That is the question. So n factor actually for the acids are different, for the bases are different, for the salts are different, even for the oxidizing and reducing agents are different. So n factor for acids in case if you take, actually we can say that number of replaceable H plus ions, number of replaceable H plus ions, that is n factor for the acids, right? For example, in case if you take HCl can be dissociated into H plus plus Cl minus. So what is the n factor in this case? N factor equals to 1. Clear? Then second one, say H2SO4 if you take, then it can be dissociate 2H plus plus SO4 minus 2. So how many H plus ions are dissociated? 2. So n factor have to take it as 2. Clear? Then third one, sir, in case H3PO4 is there, then it can be dissociate 3H plus plus PO4 minus 3. Then n factor you have to take it as n factor equals to 3. So some other is there, H3PO3, the exception case important also. Then factor for this is, sir, here it can be dissociated into 2H plus plus HPO3 minus 2. Like this it will be dissociated. Sir, here you have a doubt, why 2H plus only dissociate, other H it is not dissociate. The reason is in case if you observe the formula P-double-O, then OH, then OH, then H. So these two hydrogens only can replace because in between the O and H ionic bond is there. But here the P and H, there is no ionic bond, it is a covalent bond. Covalent bond ఉన్నప్పుడు dissociation జరగదు, ionic bond ఉన్నప్పుడే dissociation జరుగుతుంది. కాబట్టి స్ట్రక్చర్ ని బట్టి మనం చెప్పాలి. So here The n factor for this is 2 only. Clear, my dear students? Next one. So H3PO2 will be there. So it can be dissociated into H plus plus, then H2PO2 minus, like this will be there. Even here also, that based on the structure, this is also very important. So very important. So structure, if you observe, phosphorus, then double bond O, then OH, only one ionic bond will be there. The remaining are H, then H. See, look at H3PO2, right? So if you observe the structure, only one OH which is ionic, that can be dissociated. Understand, my dear students? Yes, look at all these noted. So n factor for the acids, n factor for the acids. Yes, next one. So n factor for bases, n factor for bases in case if you take, then n factor for salts, and n factor for oxidizing agents. So n factor for bases, n factor for base, how can you define, man? Number of OH minus ions, replaceable OH minus ions, replaceable OH minus ions, that are n factor for the bases. For example, look at, my dear students, NaOH is there, it is one of the base, right? It can be dissociated into Na plus O plus OH minus. Any OH minus ions replace II, one OH minus ion, right? So the n factor for this is 1. One factor for this is 1. Then in case MgOH taken twice, if you take, then it can be dissociated into Mg plus 2 OH minus. Then n factor for this is 2, right? Yes. Then AlOH taken thrice. Even this is Al plus 3 OH. So how many OH minuses replace? 3 are there. So n factor is 3. So for the bases, we can say that the number of OH minus ions, the number of replaceable OH minus ions indicate n factor of base. So next n factor for salts, in case if you take salts kanaka తీసుకుంటే, then total charge of cation or anion కానీ cation కానీ తీసుకోవాల్సి ఉంటుంది ఇది salts కి. So for example, in case if I take NaCl, it is one of the salt, right? It can be dissociated into Na plus Cl minus. So n factor, what I told, total charge of cation or anion, cation ది కానీ anion ది కానీ తీసుకోవాలి, రెండిది కలిపి తీసుకోవాలి. So charge of cation for this is 1. So magnitude of the charge you have to take. Then MgSO4 is there, for example. Then it can be dissociated into Mg plus 2 plus SO4 minus 2. So what is the n factor for this? 2. Why? Because the charge of cation is 2, the charge of anion also 2. Then most important one is Al2SO4 taken thrice, aluminum sulfate. It can be dissociated into 2Al plus 3 plus 3SO4 minus 2. Look at the n factor, how much you can expect, man? So actually you will say that 3. No, it is not 3. 2 3s are 6. So positive charge plus 6. Then even look at negative charge, 3 2s are 6. So minus 6. So either cation charge or anion charge. So 6 is there now. So that's what the n factor is, 6 for this. Okay, so this is the n factor. Then finally, we'll discuss the relation between normality and molarity. Relation between normality and molarity. Relation between normality and molarity. Normality and molarity. Look, my dear students, the normality is there. Normality into gram equivalent weight. It is equals to molarity into gram molecular weight. So in case normality is required, normality equals to then molarity into gram molecular weight divided by gram equivalent weight, right? So I told that in the previous discussion, the gram equivalent weight equals to gram molecular weight divided by n factor, right? So in case n factor is required, n factor from this formula, n factor ఎటువైపు సెండ్ చేస్తే సో ఏమవుతుంది గ్రామ్ మాలిక్యులర్ వెయిట్ డివైడెడ్ బై గ్రామ్ ఈక్వలెంట్ వెయిట్ అవుతుంది. సో గ్రామ్ మాలిక్యులర్ వెయిట్ డివైడెడ్ బై గ్రామ్ ఈక్వలెంట్ వెయిట్ ప్లేస్లో ఎన్ ఫ్యాక్టర్ని యూజ్ చేయొచ్చా? ఎస్, యూ కెన్ యూస్. సో నార్మాలిటీ ఈక్వల్స్ టు molarity into n factor. Okay, clear, my dear students? So this is the relation between the molarity and normality. So remember here one of the point, that is n factor in case 1 is there, n factor ekkadaina 1 avutundi ante, so in that case normality equals to molarity normality rendu kuda same avutayi. Okay na? Yes, up to now the discussion is over. Tomorrow we'll discuss about the Henry's law and Henry's law concept. Whatever the important topics are there, important questions are there, previous year questions that we'll discuss, and based on Raoult's law also is there some of the problems that we'll discuss. Please share and subscribe my channel to your friends, and those are relatives are there, those are preparing for the JEE Mains and EAPCET examination. Please share.